We're given a curve in the xy plane defined by xy squared minus x cubed times y equals 6. I want to find dy over dx. So this is really the same thing as y prime. Okay, so I have xy squared minus x cubed y equals 6. I'm going to take the derivative with respect to x. So for the first one, I'm going to use a product rule. So I'm going to take the derivative of x first, which is 1, multiply it by y squared, plus take the derivative of y squared. And for the derivative of y squared, you want to apply the power rule. So you're going to bring down the exponent, subtract 1 in the exponent, and because y depends on x, you want to take the derivative of y. So that is y prime. Or if you want, you can write dy over dx. Same thing. So this is just a derivative of y squared, and then we have to multiply it by x. Now we move on to x cubed times y. So I'm going to factor out the minus, and I'm going to now take the derivative of x cubed times y. Here we have to use the product rule again. So we'll take the derivative of x cubed as 3x squared, multiply that by y, plus take the derivative of y, so that's just y prime, or dy over dx, multiply that by x cubed, and the derivative of 6 is just 0. So I'm going to simplify. I have y squared plus 2xy y prime. This negative is going to distribute to both. So I want the derivative on one side. So let's see where the derivative is. It's in this factor and this factor. So pull it out. I have 2xy left, and then minus x cubed. I'm going to throw the y squared and the negative 3x squared y to the other side. So that's 3x squared y minus y squared. And I'm going to divide both sides by 2xy minus x cubed. And this is my derivative, which is dy over dx. Okay, so this is for part A. For part B, we want to find an equation for the tangent line at each point in the curve with x-coordinate 1. So with the tangent line, you need two things. You need a point and a slope. We're only given the point x equals 1. So we want to figure out the y coordinate. So let's go back up here. So it's xy squared minus x cubed y is 6. So this is my original function. So in order to find what y is, I'm going to plug in x equals 1. So that's y squared minus y equals 6. I'm going to move the 6 to the other side. And this can get factored. So it's y minus 3, y plus 2. So we get two answers for y. We get 3 and negative 2. So then the point becomes x equals 1, y equals 3, and x equals 1, y equals negative 2. Next, we want to find the slope, and the slope is just a derivative at the x and the y value that we just found. So first, if we look at 1 comma 3, the slope, well, if I just plug it in to my derivative here that I found in part A, I get 3 times 1 squared, which is just 3, times y is 3, minus plug in 3 for y squared, and then x is 1, so I'm not going to bother. 2 times 3 minus 1 cubed, which is just 1. Simplify. I have 9 minus 9 is 0. Yeah, so it's just 0 over 5, so that's just 0. And then if I plug in negative 2 for y, I get, let's see, plug it in. I get 3 times 1 squared is just 1, and then times y is -2 minus -2 squared over 2 times 1 is just 2 times -2 minus 1 cubed, which is just 1. So that's -6 minus 4 over -5. So that's just positive 10 over 5, which is 2. Okay, so the slope there is 2. Now, it did ask us for find an equation of the tangent line, but I'm going to show you how to find both. So for the point 1, 3 and slope 0, this is just a horizontal line at y equals 3. So the tangent line is y equals 3. At the point 1 comma -2, the slope is 2. So we'll just use a point slope, y minus y1. So the two negatives will cancel. Is a slope times x minus 1. Simplify, you get y equals 2x minus 4. So I found two tangent lines. So part B is done. Now let's go back to part C. We want to find the x-coordinate of each point on the curve where the tangent line is vertical. So tangent line is vertical, so that would just look something like this. It just looks like a vertical line. And that's when the derivative is undefined. So if we go back to our derivative, we basically want to see when it's undefined. In other words, when is the denominator equal to 0? So that's 2xy minus x cubed is 0. I can factor out an x to get 2y minus x cubed. I'm sorry, x squared. We get x equals 0. And 2y minus x squared is 0. In other words, x squared is equal to 2y. So we can actually find where the point is. If x equals 0, I can find out the y value by plugging it into the original function. So the original function was xy squared minus x cubed y equals 6. We said x is 0. So if x is 0, this is actually not on the, x is 0 is not on the point, not on our graph, because you get 0 minus 0 equals 6, which does not make sense. So 0 is not part of our curve. Okay, and for x squared equals 2y, I can plug that in. So actually what I'm going to do is y equals x squared over 2. Okay, and I'm going to plug that in for each y. So it's xy squared, so it's plugging in x squared over 2 for y, minus x cubed y. Y is just x squared over 2 equals 6. And I can solve for x now. So I have x squared squared is x to the 4th over 2. Multiply that by x is x to the 5th over 2 squared, which is 4. Then x cubed times x squared is x to the 5th over 2 is 6. I can combine these two, same common denominator of 4. So that would be x to the 5th minus 2x to the 5th over 4 is 6. And so multiply both sides by 4. I get negative x to the 5th is 10. So x is equal to the 5th root of negative 10. And in order to get y, we know y is x squared over 2. So if we plug that in, we have y equals, we'll just write it like this, negative 10 to the 1/5 squared over 2. That just becomes negative 10 to the 2/5 over 2. So this is the y value and this is the x value, where there's a vertical line, tangent.